Hi, my name is Simon, GM8NYV. I'm continuing on the restoration or repair of the CR100 that I've started about a week ago. Last time I took off the RF component board and it was quite black. I removed all the old components. It was quite dirty, so I gave it a clean. I cleaned it in a bowl of warm water with some bleach and used a toothbrush to give it a good scrub up. I was quite surprised after, and then left it soak for a while. I was quite surprised at the end. The water turned brown, like a nicotine brown. I think there was quite a lot of nicotine soaked into these boards. Anyway, this is the board. I've squared up these as well, just sort of straighten them out. They're actually made of brass by the looks of things. And I've also rubbed down with a small needle file to get them a bit smoother. Don't know if you can see that. I've labelled them with, use one of these label makers from Lidl's. Where's brother? Some from Lidl's. And I made these little labels up here. Oops. Let's see, roughly. Repeat, those are a bit big. This is the bottom as well. So that's came up quite good. It's still a bit weak there, and that's where those two larger resistors were, where they burnt it a little. I'm not sure what to do with that. I might just give it a bit of a varnish or a lacquer. But then if it's going to get hot again, I'm not too sure. I've put R40 here, and I labelled R39. These get hot, so I don't want these to melt. If they do get hot again, I don't want them to melt. So basically ready to put the new components on here. Now the old components, the old resistors, some of the very early resistors that are on it, I think after the Second World War they started to standardise them into series E24. Basically that's, and E12 is basically standard values, and the E24 is 24 per decade. So that, if you can see it, is a 4.7k resistor. It's red with the yellow is the first significant figure, that's the body. There's a stripe at the end, the violet, that's 7, and the red is the multiplier, in this case 2, so it's multiplied by 100, so it's 4,700 ohms, 4.7k. Then later on these appeared. Now this is, I took this off this board, so this is obviously a later edition. This is 47k. Probably, if you know the colour codes there. So you got 4, yellow as the 4, first significant, the violet the second significant, 7, and the multiplier, in this case orange, meaning 1000, that's 47k. I'm not going to use these are carbon resistors, and I've gone out of tolerance. Little go, the little silver band there gives it, I think that was 10% tolerance, but even it's higher than the 10%. So I've got these metal film, the half-watt resistors. These are half-watt resistors as well. So these modern metal film resistors, Smart 47k, it's a bit harder to read the band, especially these ones. But I'll do that way. But you can see it. They've got a few more bands on it. You've got the first significant as a yellow, second significant as a violet. Oops, very hard to see where you get in focus on that camera. Then you've got a third significant, was a 0, a black 0, and then a red band, the multiplier, so it's 2, it's 100. So you got 4, 7, 0, and then 2 noughts. That's 47k, so that's the 47k. Look at my little book here that I made of the diagram. So the first, I'm going to work from right to left here. So my first resistor is going to be R40. I'll stick that on in a minute. R40 is 47k. I'm not going to make a video of me doing every resistor. I'll be here all night. Got a solid line on here. Right, I had a question. Someone asked me a question about cables, and I wrote it down, the cable I wanted to use. They were talking about using cloth covered cable, UL 10 1015, I think. I had to look that spec up actually. But the cloth covered cable is quite thick as far as I could see. Now, I can see the point of using cloth covered cable if you want to keep it authentic. In my case, I'm not so worried about authenticity. I don't want to change the design or anything, and I'm going to try and use the same valves, everything like that. The only thing I'm bringing up to date is the capacitors and the resistors. Now this is an example of the cable that came off. This is a piece of rubber that actually hasn't perished. Now in the manual, I have a manual here, an official Marconi manual for the CR100. It's got a couple of pages ripped when I got it off eBay, but I've got a copy of it there. And they stated the cable is 14/0076 inch square Hamofill. So I suppose that's what Hamofill is. The 14 are the 14 individual strands, and twist them all together, and overall got burn you here. It's about 0.7 millimeters in diameter. You're not able to see. You're not going to really be able to read that, but it's 0.7 millimeters. Now then, looking for something equivalent that I've been using. This has a 0.0006 inch squared, which is equivalent to about 0.39 millimeters squared. Now that has a 2 amp rating. Now the more modern one I'm going to use is 0.5 millimeter, and you can get Farnell sell it. There's a few more. I've got quite a bit kicking about off cuts and stuff of 0.5 millimeter PVC insulated 20 AWG, I think. The external diameter of that cable I'm using is 1.27. This is about just over 2 millimeters. So with the rubber, it's quite thick. Now the cloth covered stuff looks quite thick, and there are a few spaces you might not get it in. If you remember on the last video, there was the metal plate, then there was this, and there was a very thin gap underneath of a couple of millimeters. Now 3 of these cables were underneath it, sandwiched between the bottom plate and the top plate. It was just to make it look neat. It came in from a hole at the side of the radio, went underneath, curled over, soldered on here. I mean, there's no reason why you can't take them over the top. The metal plate, incidentally, has a centimetre by ½ centimetre cut out at one end where it meets the chassis. Now there are 3 small coaxes going through there, and quite a few cables. So if you do want to use cloth cable, and I don't have the figures in my head at the moment of the thickness, it'd be quite a tight squeeze at that end and possibly underneath. But certainly the person who quoted or asked me the question, we're talking about 105 degrees at 600 volts. So that's certainly, the specification's fine. I'd hate to think if this went up to 105 degrees, we'd be boiling a cup of tea on it. But 2 amp rating for the internal. I mean, it may be 350 volts, I think, the HT, but don't forget it's going to be very, very low current. Right, so I'll start on to solder the resistor on here. I'm going to start with R40. I'll move the camera down. Well, that's my phone actually. I'll show you can see that. These actually, they have little hoops. Oops, they have a little, hard to see. Point it out to be. Yeah, maybe there. Got a little hook there, and a little hook on the opposite side. First of all, I thought I'd wrap it around the hooks, so it might work. I'll try and get them all running the same way. So I'm going to run it down the way. So the first significant figure I'm going to use red for the 47K is going to be yellow, and I'm going to use it on the top. So I'll put it that way. Not easy to do it. And try and get it squared on there. So I'm just going to push that through there. Wrap that round, not too many times round, and solder. That's sometimes use flux. Helps it flow a bit. So a bit of flux. I know it's resin core solder, but I'm putting a bit of flux on just to tag it on, so I can then make a neat job with the other side. Then I can tighten this one up. Right, pull it tight. Now, tempted to go across and use the hoop there. So, a pair of pliers into the little hoop. That one I can get quite tight. Underneath. Again. Something to stick it up on. Oh, a bit easier to see. It's not going to stay. Never mind. Right, get the gist of it. Right, this I shall solder in here. Now that let's finish off the back one again. Let's get this a bit tighter. So this is all I'm doing, just putting solder on there. Look at it. With a magnifying glass here. Handy to have a magnifying glass. See any bad bits? Nope. So quite happy with that. And in the drawer here, just snip it off. So that's basically one 47. Make sure I did put the right resistor on. Yeah, 47k. Always best to check. Right, I'll just pause that and I'll do the rest. Well, I finished putting the resistors on. Right way up. So you can see there from R1 on the right as you look at it, I suppose, all the way up to R20. These three other resistors here are the high wattage ones, which I haven't got yet, so I need to source some of those and put them on. Do something about this here. I don't know if you spotted it before. I actually put R1 at R40, so I turned it round. So I've chopped it off and put it on that end. Spotted it just as I was about to put the next resistor on. So that's not too bad. They're all 1/2 watt resistors on the thing. I put a bit of cable in there, a bit of lying around a link. I think I'll get a proper, it's not the proper cable I'm going to use. Just thought I'd give it a quick trial. So there's a link from here. A few more linked, and then there's a link over the top, so I shall get the proper cable to do that properly. So that's it with the backing. Once it's finished, I'll put it with the rest. So now I've got 3 boards. Boards out with the backings. So there's another board, that's a little board done. That goes on the back, all this plastic. And the other, that's 3 boards. There's one more board to do. So what I'm planning now is to do the last board, to actually with the components on. This I didn't use insulated wires between the links. They're so small, it's not worth it. You can see it, point it out there. Yeah, I just used solid core. In fact, I think it was a part of a component lead. Same on that one. Same on this one, I just used solid cores. But because of the long spans on this, I'm going to use proper cable. This is just a piece of cable that's lying around. I don't even know where it came from, but I get the right stuff and do it correctly. So 3 boards down, 1 more to go, and then from there my plan is to start removing the components around the valves and document where they all go. I'm still not sure if it's here, making up a wiring plan. Oh, what I mean by wiring plan is I'm looking at a circuit diagram. I'm going to make a little catalogue, say R11, and then mark where R11 goes. Like R11 goes to valve 2 pin 5 or something like that. That's off the top of my head. And then from there, whatever. So I'll have a little, like a map, a wiring map, make it easier to put together. So that's going to be quite an involved job, I think, to get it all right. After I've cleaned up all the valves, I'm not going to take the bases out. I looked at them, I thought they're all riveted in. It's a shame to remove them. They look quite clean. So I'll have a good look at any broken, if there are any broken ones, and I'll obviously replace them. But at the moment they all look very good. The other thing I want to do after taking all the valves out is probably remove the transformers. The mains transformer, which I thought I'd leave in, but I think I'm going to take that out and use heat shrink and cover the cables there. The transformer's quite good. It's just the insulation is breaking down on the cables, well, flaking up. So I shall use new insulation on the cores leading from the main transformer. There's 2 low frequency chokes. I will take those off. I shall also take off the audio frequency transformer. And my next video, I think I'll do a few of these. I've got some more. These are capacitors now. These arrived. These are 100 NF. 100 NF. Basically 0.1 UF. And they fit nicely inside there. So I'll do a demonstration of cutting this off with a pipe cutter, cleaning up the ends. This at the end, I'm not sure that was deliberate at the very end of them. Find what I've done. No, I haven't got one here. I'll mention it in the next video. Whatever's in there is a piece of this Paxlin basically underneath a terminal in it, and on top it's like an epoxy. It's all black, it's all burnt, and I found it actually conducts. And I didn't realise that until I'd measured the capacity, quite accurately, 0.1. Put it in the can, pushed it back on. I've glued this back on, and the capacity went up, and it took me a while to work out why. And then I realised once you cut the can, obviously you're going to oxidise almost straight away the aluminium, and when I pushed it back on, I probably got another capacity there. Now with that capacitor on there, and with whatever's in the end of this gungy stuff conducted, basically I put 2 capacitors in parallel. So once I picked out all this horrible stuff, burnt wax, and it was okay then. I measured it and it was 0.1. So that's what I'll show anyway when I do it properly. I'll do it next video. I'll take these components apart and show you how I make them up. I mean, you could just put those capacitors straight in if you wanted, but I think it looks better because these actually bolt onto the chassis with little. I think it looks better. I say I'm not after 100% authenticity, but I think that looks better and it's more protected than covering this in insulation and just having it lying there in the radio. Anyway, thanks for watching. If you like it, click a like button, etc. That's what everybody else says. So I'll see you next time. Bye bye.